Okay, right, let's see. Just make sure everything is working. You know. Apparently it says connection works. Okay, right, let's see. Yeah, okay, good. It works. Alright then. In that case, we can close this. Welcome to C without libraries. Which was it? It was nolibC. I already actually did a bit of looking into this in C no STD. If I go nvim src main, okay. In here, I actually did a bit of understanding how I would actually do this. So this was yesterday, like at midnight. I didn't want to stream it, but now I'm actually going to be streaming it. So yeah, we're gonna be remaking all of this. I'm gonna completely ignore what I have right now. I might have to look at this every once in a while, but hopefully I won't. Hopefully I can go off of my memory of how syscall works. So, you know, so let me just go back and into nolibC. So this is where this is where we're going to start working. I've made a source folder, and inside of the source folder we have our include folder. So we're just going to make makefile as well. Now I'm not really good with makefiles, so I'll just try something out. So I really have no idea how makefiles work, but for now I'll just do gcc dash I forgot what it was. I think it was like no stdlibs. I know it's -w because otherwise, like, we'll get warnings for, oh, you've reused definitions from standard libraries. -o main, I guess we'll call it. And then for now, it's only main.c. I need to check, actually. Wait. Nolib. Wait, this one. We have a makefile. No stdlib like that. And then if I just go to the other window, nolib. Oh wait, I didn't necessarily make a file, so let me just make a file. I'm pretty sure it's a yes. Make file like that. gcc no stdlib. Okay, yeah. Okay, so main gcc dash no stdlib like that -w for suppress warnings -o main, and then we're just gonna need to put in main.c, which is what we're gonna have for right now. So let's quickly save that. Then we're gonna go back into this window and let's just make in our source, we're gonna make main.c. And in here, we're gonna put in our, well, we don't really have much, so for now, all we have is void, I think it's underscore start. And, yeah. That is our program right now. It's already a great program, as you know. Okay, so we now have a make file, so if we just run make, we should get a main. Okay, segmentation fault. Oh, great. I didn't even have... God. Well, I mean, we have a main. nvim src slash main.c. Okay, so... we don't have any includes. We can't really include anything. So the first thing we're going to need to do is somehow write sysexit. So for that, I'm actually going to go to here. I'm going to do Linux 64 unstd syscall table. Okay, this one is on. Okay, so here's what we're going to be using the most. It's a great thing. We have, well, we have to put in each one of the registers and what it does. So if we put... Where is exit? We need to find exit. Socket pair for... Oh, okay, 60. So, So we're gonna do. This is, by the way, this can only be done on Linux. So we're gonna put Linux Ubuntu. I'm not sure if this is only Ubuntu. I'm just gonna put Ubuntu here. Linux 64-bit. Right. Oh, it automatically continued these. Okay, right. So we're gonna define exit, or I guess I'll call it sysexit, as 60. Okay, that's already good. So we're gonna need to make, and I think I'm gonna make this all inside of a different function, just so I have this stuff. So we're gonna include our own file. So include. We're gonna call this mlib.h. So this is like, you know, stdlib but with m instead of std, because I'm qxf. Okay, so we're gonna write that. We're gonna open up our tree, and we're gonna make. Well, first of all, we're gonna make mlib.h. And oh wait, that's not. How do I delete that? I'll rename it to include mlib.h. So there we go. And let's also make mlib.c. Okay. So now, oh yeah, also I need to go back into here, and I need to reset this because I did the wrong thing. It should be include / mlib.h. Okay. Okay. Alright then. Let's move over into here. Let's go to mlib.c. Here we're also going to so actually we're not going to need to define that in there. Instead, we're going to need to define these in here. So we're going to go to, first of all, again, I'm going to put Ubuntu Linux 64-bit. I'm just going to put this as like the top of everything. Define sysexit as 60, and then we're going to do include mlib.h. No wait, include / mlib.h. I put the wrong thing. .h. There. So now we have to make our void sysexit. And we're gonna need to put in our, I think it's int error code. Well, actually, the best way to find out is to actually go onto our amazing page right here. So, in exit, yeah, it's an int error code. So we put 60 into the A register, and we put our error code into the capital D register. Or at least that's like how it would work on in C assembly. So what I need to do is ASM volatile. I'm gonna open up our brackets. Okay, so in here we're gonna first need to write syscall. Nothing goes into inputs. Now outputs, we know we're gonna need to have, or I mean, no, that was outputs. Nothing is in outputs, and in inputs into A we need to put in sysexit, and into D, I think, yeah, D we need to put error code. Okay. So that should do that. And I know there's like another thing which I could put in there, but I'm gonna try without that first. Why is that complaining? Oh my god, I don't remember anything from doing this yesterday. What exactly? Expected identifier. Oh wait, yeah, no, because I put... I'll just write this in lowercase, sysexit. There. I think that should be better. Right? You're not going to complain now. Okay. I don't know why you're complaining about that. Oh, ASM statement. Yeah. Okay. There. Do I remember how to make ASM statements? Kinda, you know. I remember certain things. So let's go into main. And from here, let us call sysexit 12. I'm pretty sure 12 was the number. So, let's try this out. So, make. Okay. Undefined reference to sysexit. Oh, yeah, I forgot to put it into the, include file. Okay. So, how do I make libraries? Oh, God. Ubuntu Linux 64-bit. Okay, right. Hashtag, I'm pretty sure it's if and def. Okay, good. If and def. And we'll just call this underscore. Because I think stdlib is like stdlib like that or something like that, isn't it? Or is it just stdlib? I have no idea, but I'm gonna call it underscore mlib underscore. I think like that. Hashtag define mlib. Oh, not mblib. Mlib. Hashtag ndef. And then we also gonna need to put then void sysexit int code. Okay. Okay, I don't know why you're erroring. Oh yeah, because of course comments aren't the same. I think. Whatever. We'll just not put comments in the header files. Okay. So what if I make it now? It still says it's undefined. Okay. I completely do not know how these like libraries work. Include well, because I put it here. If and def, define that. What did I do wrong? What did I do wrong? What am I forgetting about? Oh yeah, because I forgot to include there. That's what I'm forgetting about. src/mlib. I really need to figure out how freaking these files work. I am really not. No, not mlib. God damn it. Oh yeah, .c. I wrote .h. Okay, right. Ooh, it works. Okay, right. /main. Hey, we got a system exit. We have managed to get the system to quit. All right, that's progress. That is progress. Oh my God! Right now, envim main dot envim src/main.c. Okay, so what else do we need to do? Well, now we need to. So this is an stdlib. Up next, we need to have stdio. We want to. I need to remove this. We want to define printf, all of that stuff. Printf will be quite a challenge. I know that. So let me just go into, and I'm gonna make a new file. mio.h.c, I mean, and in here, and then we're also going to make mio.h. So for now, let's go into mio.c. No, not mlib. Mio, and we're also gonna quit this. So first of all, we're going to run at the top here. Well, we're gonna just do my normal thing of saying this is Ubuntu Linux 64-bit. Okay. Then we're gonna have to define syswrite, and I need to give it a number, and we need to define sysread, and we need to give it a number, and we're also gonna need to include include slash mio.h, and I don't think we're gonna need mlib until later. So, right, let's find out first of all what these numbers are. So we have, I think they're like, yeah, 0 is read, 1 is write. Okay, that makes my life easier. So so read is 0 and write is 1. I'm also gonna need to find stdlib.h. I'm just gonna lib.h. I'm just gonna look through. Yeah, that's nice. That's nice. I give me all the functions, so I know like where I can find different functions. So if I also search up stdio.h, because obviously if I have a function, I want to put it in the right put, and I also need to search up string.h, because I know this one probably is going to be needed, because we can have, okay, so we have all of this stuff that we need to figure out. Okay. So obviously the first thing that we need in stdio, we obviously have all of this stuff, which might be a bit for the file stuff, but what I'm looking for right now is anything that includes console IO. So scanf, we have scan fgetc. What is this? Formatted string input from a string. What does that mean? This is the input from stdin. But what the heck is input from a string? Is that also like stdin? I have no idea. Okay. We know this is gonna be great. We have get char from stdin. We have put char. Okay, so I think we should probably get through the right ones first, because obviously we're gonna need a printf as well, and just a print as well. So those will need to be like where, because if I look at, I'm assuming this is like inside of UniSTD or something like that for the Unix. It's gonna be just like read and write. So, like just the base. Let's see. So if I just write here, okay. So void sys read. No, sys write. Let's do sys write first. Okay. I don't know if this is the best. I think I'll just call it write. Right. Okay. So we're gonna need a first of all. So write first of all requires a file descriptor. So it requires one for system. And what is file descriptors? Wait, file descriptor Linux. Every file associated. I want to like specifically find if there's anything gives access. Read only, write only, read write with a. Oh, okay, right. This is what I need. std in, std out, and std. So basically, if we're reading from std in, we're reading from 0. If we're writing to std out, we're going from 1. So this is the same as like the function calls. And if we're and standard error, default data stream relates to an error occurring. Okay, I guess we'll have to handle like exit handling. So we can completely ignore file descriptor then, as long as we remember that 0 is inputs, 1 is output for now. So that's what we put in capital D. In A, we're going to put obviously the system call number in the right. Then we have our constant pointer, and then we have our size count, which size t, which I'm assuming I'm going to need to define inside of stdlib. And now I need to find out how to define shit inside of H files, because I've barely ever worked. Define type def in H files. Okay, I'm just gonna see what this is. So Oh, it's just like a type def. You just put it like, so you literally just put it as C. So I don't need to worry about that. So all I have to do is I can just say define inside of oh wait. If I just go into mlib, what I have to do right here is I have to just put. Do I have to put hashtag define? No, wait, I don't. I just have to put type def. Type def. And then we'll call it int. Wait, no, it has to be unsigned. And I'll just make it unsigned. Yeah, size t. I need to figure out what is size t as a variable. What is size t? Because I know it's like I know I'm pretty sure. Yeah, it's unsigned integer. But like, is it like long or short int, or is it just unsigned integer? I mean, thank you so much, stdio, and I'm assuming this is defined in like stdlib or stddef, I guess. Well, luckily I have access to what's called computer. Should be, I think, in USR include. Is std stuff in here? stdlib. Okay. I don't care what I open it with. Include stddef. External size t. Oh wait, no, that's just the. So yeah, this is defining any like kind of things like failure, exit failure, exit success. Type def struct. Whatever this is, I don't really know what that specifically does. I think it has to be an stddef then. So stddef, wherever that is, where was that? I swear I saw it somewhere. stdio. stdint. Well, where on earth is stddef? Wait, that doesn't exist here. What does this have? Maybe this has like stdint. Type def. Int least 8t is an int least 8t. Yeah, okay. This is. Oh yeah, you add two underscores to the bottom of it. Okay, that makes sense. Yeah, very useful. Oh, hello Avocado. How are you doing? As you can see, I'm trying to code without standard libraries by looking through standard libraries and trying to recreate them. So int fast. Oh, so basically, so all of these are just like, you know, deft, and then we define them again as u underscores. Okay, makes sense. So we're looking for a size t here. So there's a bunch of like random definitions for max size or whatever else. Is there nothing about size t in here? That's sad. Okay. So it's all apparently in stddef, but I don't see an stddef. Maybe it would be in local include? No way it's in local include, right? USR local include? No, that's just Node. That's just Node.js. Is there any other includes that I might need to know of? I mean, because the standard libraries should all be in here. Actually, let's go back to std. What do you call it? stdlib, right? What does it include? It includes, yeah, just stddef.h. So somewhere in here there must be an stddef.h, right? Or does it just not exist? It just doesn't exist, and then my own stddef is the only way to go. Let's search for stddef. Okay, there, I found it. Great. If not, if not defined always inline, define always inline and inline and if. That's so useful. Oh my god, more people saying E. Okay, well, looking through this is pretty useless, so I'll just take size T as being an unsigned, just normal unsigned, because that's an integer. So, we're gonna need, obviously, an unsigned int for the file descriptor, constant char for the buffer. Okay, so let's just, so now we have that in mlib. I don't think I need to define this inside of, inside of the mlib.c, so I should be able to go into here and reference mlib. So include slash mlib.h, and in here all I need to do is then const char pointer buff, because I'm pretty sure we always know we're going to be outputting. Actually, you know, just in case, I'll put in unsigned f file descriptor, const char pointer buffer, and our size underscore t size, right? What does it call it in there? Because I'm gonna just copy these. Count. I'm just gonna like make it so that it's like exactly what the system likes. I mean, I know it's not really gonna matter. And does it return any value? I don't think write returns any values. Nah, it doesn't. Okay. So in here, all I have to do is just ASM, open close brackets, and in here it's gonna be a syscall, nothing in output. Inputs for A, we're gonna have syswrite. What do we put into where? So in capital D we put in FD, in capital S we put in buffer, and in lowercase d we put in count. So capital D we put in FD, capital S we put in our buffer pointer, and in lowercase d we're gonna put in count. So technically that should give us an output to the console screen in the most simplest way possible. We're obviously gonna have to like define this first inside of our. Oh, what do you not like about this? Oh, did I put a dot here by accident? There. And then we're gonna need to put into here if and def underscore mio hashtag define mio. Actually, since I was looking through the files, might as well look at how they define their stuff. Right, when I go into, no, not that, computer usr include. So let's just say, for example, sddio. How does that? So if and def just underscore stdio underscore h. Okay, I'll make that. So it's like that. Okay. I'll follow their standard. So if not defined underscore mio underscore h, define mio underscore h. Okay. Hashtag and if Okay. Then we're gonna have our void write. Let's see, and we're gonna need to put our unsigned fd const char pointer buff, and we're gonna need to put our, what is it, size underscore t count. I assume because I'm using size t here, I need to also hashtag include, and I don't know if I need to, like, would mlib should be possible from here, right? Because this is inside of the include folder. Oh wait, I forgot to add this. So we're gonna include hashtag include slash mio.h, and we're gonna do write with 1 because we're going to std out. We're gonna say hello world. Why not? Because that's how we will start, and then that's 11 characters. So theoretically, this should print out. Okay, right. Undefined reference to write. What do you mean? Oh yeah, I forget. I keep forgetting every single time. We need to update the make file. src slash mio.c. Okay, right. Okay, now? Okay. Okay, it worked! Oh my god, we have our write function. Okay, now let's make a slightly better one. Obviously. We're gonna create our print function. So, we're gonna go back into our mio.c, and we're gonna write a print function. So this isn't gonna be printf because printf takes an undefined, like a variable number of arguments. So we're just gonna write void print for now, and it's just gonna have const char pointer buff. So this is gonna be my first like actual function. We're then gonna have to also write printf, but you know. For now, print. Printf because we need to like add the whole formatting it. So for now, we're going to also create one in string, I think, because we need to find out the length, because like the length of a string, which I can do in. I'm assuming this isn't like something that's included in stdlib. strtol? Okay, so wait, that's in stdlib. Converts string pointed to allocates. Yeah, no, I know that. Deallocates, allocates requested memory. Is there anything that's like? No, I don't think there's anything. Okay, whatever. That's fine. That's fine. That's fine. That's inside a string, right? We have strlen. Right? Yeah. Size t strlen. Const char pointer string. Computes the length of the string up to but not including the terminating null character. Okay, so it doesn't include. That's fine. So we need to go back out to here, and we need to make mstring.c in here and mstring.h in here. So let's just go into here. We're gonna need to obviously include more things. This is actually gonna get quite complicated. Include, wait, first of all, Ubuntu Linux 64-bit. Okay. So then we're gonna hashtag include slash mlib. We're gonna have to include mlib because we're gonna reference size t. So then we're gonna say size underscore t strlen const char pointer buff, I guess, because that's what they always use. So basically, because we have a pointer, right? It just takes it takes str because it's fancier. String takes str. Okay. So then we're gonna need to get, which I think actually we could do. So we're gonna return a size. So size t len is equal to 0. Then while pointer str is not equal to It needs to be a terminating null character. Oops, wrong one. We're gonna do len plus plus and str plus plus because we're gonna add to the pointer, and then we're gonna just return len. Okay. And we're also gonna need to include our string.h. So, in here then, okay, right, so we're gonna then move over into mstring.h. Why is that complaining? What is that complaining for? What have you got wrong? Incompatible library function. Shut up, I'm not using standard libraries. Okay? Stupid thing. So, hashtag if and dev underscore mstring underscore h hashtag define underscore mstring underscore h and we're also gonna, and then in here we're gonna put s. Oh yeah, we're also gonna need a hashtag include mlib.h just so we get our lovely size t. So then we're gonna say size underscore t strlen. We're gonna say strlen. We're gonna put in our const char pointer str. So there we go. Now we've referenced that. Right. We're gonna. So that has our our function right here, which shut up about it being a library function. So then in MIO, we're gonna hashtag include slash mstring.h, and we're gonna in the print we're gonna first of all so actually we're gonna need a just whole right with one. What does that mean? Yeah, one because it's assist right. Char buff would just be buff. And then size t would be strlen of buff. So theoretically, that should work. Now let's go into main, and here instead of writing, also that just expanded a lot, I'm just gonna remove this, and we're gonna say print, and we're just gonna put hello world. And let's also give it a \n character, just so you know we have that stuff. Oh my god, is this msting? Oof. R mstring. There. Okay, so we're gonna do nvim make file. Oh wait, it has to be with a capital M. Okay, so now we're gonna need to just add our src slash string.c. So rm main make. Okay, it has worked. So now let's try it. It says hello world and next line. There we go, print works. Okay, right. We have created one basic C function. Oh my god, how long have I been doing this for? Oh yeah, just a casual 40 minutes just to get print working. You know, very casual. We still haven't even gotten print F. And printf has like a variable number of arguments, so it is just like impossible, you know. In fact, we're gonna just go into mstring.c. Wait, no, not wrong one. Colon Q. We're gonna go into mio.c, and we're gonna create another void. Printf const char pointer buff, as you know, pointer buff, and dot dot dot. Oh god, I'm gonna love this. Oh my god, this is gonna be fun. Okay, right, let's see then. Okay, right. What should we do next? Should we do... I don't really want to try printf until later. Should I do... Okay, let's do read. Let's do scanf or read or something like along those lines. Okay, right. So, first of all, let's find out what the syscalls for read are. It's 0. We put our file descriptor, which will be std in this case. So 0. Buff, which will be the place where we store it, and count, how many we're going to put into there. Question is how we're gonna like do. Okay, whatever. Let's just get our just void read done first. Void read. Again, unsigned fd file descriptor. No, just char buff, pointer buff, not constant, and then size underscore t count. I'm assuming, awesome, we're gonna repeat the exact same process. I'll remove this white space. And it's also gonna be syscall, except now we're gonna need to take stuff out of it, and this is from S again, because it's the same thing that we had here. So, select that. I should barely use mouse while using Vim. So S actually goes into buff, because that's pointer, and then the output, and then the input should be, well, for A we still have our normal sys read, and then D obviously has to be file, because I'm assuming these are the exact same things. FD and the other smaller d count. Okay. So theoretically, this should put in something into read. So let me just wait, what? Why does that not work? Wait. What are you complaining about? Invalid output constraint. What? I mean, we're taking an output from RSI. We're putting into the other ones, you know. That is interesting. I mean, I kind of want to just try it out and see if it even works. If it errors like on compiling, because it might not, but it probably will. So let's just put this in here. First of all, I don't know how we got print to work because we haven't even defined it in here. Void print with const char pointer buff, And now I'm gonna need void read unsigned fd char pointer buff and then size t count. Okay. Did I put in like Amsterdam? No, I didn't. I don't understand how that managed to reference it from main. But okay. Let me just, instead of printing this, actually here's something we can do, is actually we can print out something that's been set. So let's say we make just a char array, 11 characters, just to include, actually, yeah, 11, why not? 11 characters, I'm going to call it in. Then we're going to say read 0 in, and then 10, because 10 is the size of our of our character, the amount of memory we've allocated to it, and then we're just going to print in and print \n character, just so we have our characters. So let's just try this. Okay. rm main make. Ooh, okay. Oh, okay. I think I know exactly what's happening. mio.c. Basically, where we're taking it out, we're actually taking it out. We need to take it out with equals s. Okay, that's slightly better. Oh, and I messed up. And I messed up in the simplest thing ever. It's wrong definition. There. Okay, right. I'm gonna put hello world here. And it prints out hello world. Okay. I mean, I think I forgot to add, yeah, I put 10 instead of 11. Okay, right, we have our main make. Actually, I should put the rm main inside of make, so it always removes. I'll put hello world, and there we go! Oh my god, that is so amazing. Okay, that's already better. Let's see. I'm gonna also nvim make file, and let me just, inside of main, we're first going to, oops, rm main. Just so that, you know, we don't get any of that anymore. So now make will also remove the old one. Oh wait, never mind, it doesn't. It doesn't remove the old one. Whatever. I'll just delete this then. Okay, right, so our read does work. Now we gotta also make scan instead of read. So scan will just take in our so similar to the way prints took similar to printf, but without like the extra stuff. I'm assuming scan, what I could do is I could just scan into okay, so basically the way scanf works is really complicated. That's already great, as you know. But just normal scan we could do. We could probably do just normal scan by putting the output into a char format. My question is, would the thing that I'm thinking of work, though? Because if I just make, right, I'll make it in between these. Void scan. And then we're going to do char pointer buff. Because scanf is going to be more complicated. So we're going to have to obviously do that, which we'll do later. Because that's where we can, like, scan in integers and other types of variables, not just strings. For now, we're gonna need to make scan. So, like, my main idea is while because then we're gonna have, right, while pointer buff is not equal to \n. So we're not gonna append the \n character. That's the idea. So when it is, we're just gonna do. We're gonna put that. We're gonna read a 0 buff and then 1, and then we're gonna do buff plus plus. And then we're going to do buff plus plus again, and then pointer buff is going to be equal to terminating character, null character. I'm just wondering if that is even going to work, right? Because I don't know if it is. That's the thing. So MIO, we're going to put void scan char pointer buff. Because right now, right, this is in here. It's taking in. You know what? Let's try it. Let's try it. Main. And so instead of reading, we're just gonna put scan. Oops. Scan in. Oh yeah. RM main make. Okay. So that doesn't take in. So that is like an infinite one. Yeah. So even if we make that. Oh wait, no, I think I know what I could do. So obviously I need to exit this, and I don't think there's any way of exiting this like normally. So because the input is never ending, so we're gonna have to just terminate this, and then just go back in. nolibC. Okay, so I think I know what I could do to fix, I think part of it at least. src slash mio.c. Okay. So the first thing is it adds buff first. So it will do this, right? It will put it into buff. But then it will add to buff. So my idea is, in that case, because like this is obviously gonna be the next character, which is never gonna be \n. So in that case, what could I do? How could I make this? Because I need to first... Because the idea is, I have to put this before... before read, because otherwise... So in reality, I have to first do buff minus minus. Just to set it back by 1, so that when it adds... But then again, maybe buff minus minus is a terminating character. Huh. Because what if like one before the buffer we have a terminating character. Actually, what if I just read first? So I read again. Read 0 buff 1. So I read one character into the buffer already. So then it can compare that one character, and if it's \n, it will skip this, and it will just add a terminating character. Actually, we don't want this to be terminating character. We don't want to add this. We want to actually set the one, so that will remove the \n. Then, if it's not a terminating character, we'll add one on read. Okay, I think that would work. Nvim src/main. Oh. No, just quit. Main.c. Okay. Because this is going to, yeah, it's going to print it out, and it should only print out one new line. Rm main make /main. Let's see. So if I just type in hello, it outputs hello. Hello world outputs hello world. Just type in. Okay, right. That's scan. That is scan. That is scan working all perfectly fine. So we now have print and scan functions, which are slightly different to the way they work in the normal. But it does include some stuff. So basically, the way scanf would work, actually, would it like does scanf also take an unending amount of characters? Like if I just could I theoretically just type in like scanf and then just like %d %c %s %u %e %l and so on. Oh, hi Jens, how are you doing? I saw your video on the 2x2 hipster, by the way. I was quite impressed. Just randomly gonna mention that. So now I don't know if I want to start working on, first of all, redefining the new print functions. Or actually, wait. First of all, I want to like kind of make an int main. Wait, I actually wonder, right? If we go to main and we make our main.h, right? Could we just call int main from? Yeah, we probably could. So actually, I'm gonna try by reformatting this. Include /main.h. So we're gonna I'm thinking, because what I want to do is I want to make an integer, like int main, so like it works like a normal program, so I'm no longer in this void start, and then I can have like a handle exit code, so if somebody like exits with, returns -1, it's system exits, but it also prints out like program finished with exit code -1. Okay, so if I'm going to remove this, so this is no longer going to be the void start. Instead, this is going to be int main. And we're not going to include the args just yet, int main. And we're going to have return 0. So, so then let me just add in an include main.h. And in here, there's only going to be one thing that can be included. So first of all, hashtag, what happened? Where's my, oh yeah, because I put it in here. Hashtag, can I go into, oh yeah, hashtag if and def underscore main underscore h, hashtag define underscore main underscore h, hashtag and if, and the only thing we're going to do is we're going to say int main. There. That's all we need to be able to call main. So then, I'm assuming let's do this inside of mlib. Right. So write to that, and then let's go into mlib. Oh god damn it! Why am I in visual mode? No, I do not want to be in visual mode. Let's go to mlib. Let's include slash main, and then void underscore start, and then we're gonna make another void which is gonna be called process error main, and then sys exit 12. So we're also gonna make, so this is at the very end, the start function cannot be called from anywhere else, so we're gonna do void process error int code. So this is now me adding my own little API, I guess, style thing. So we're just gonna do if code is equal to 0. So basically, it's gonna that's if it's finished successfully, and then else if it finishes not successfully. We're gonna include MIO as well. Include slash MIO.h. So the only place where we have to include main is in here and in main itself. That's the important stuff. So we're gonna make our if code 0. We're gonna do print. First of all, we're gonna print a new line character, so it's gonna exit like out of the string that we are in, and then it's gonna say program finished successfully. I'll just put exclamation mark backslash n. Let's just print that. Else, now because we don't have a printf, I'll just put print backslash n. Program finished with error. Why not? Just for now, that's all we really need for now. Oh yeah, don't forget backslash n. So that's this process error. And we're just gonna make this, we're just gonna put this up to top. Should I yeah, I'll move, no, actually it's fine, because sysexit is down here. Okay. So now, all we need to do, write this, so just to make sure main, we also wrote that. Right, and then in main.c, now we have our int main, in which we could call some like print, hello, or for example, char int char in, and we'll give it 10 bits of memory. Scan in, and then print in, print backslash n. Actually, we don't even need to print backslash n. It's gonna handle everything else for us. So now, whatever else I forgot to save, rm main make. Okay, so now main should still have our like normal way of functioning, and there we go. Program finished successfully. And also, it has up to, I think, 10 characters. So if I just run this and I add 11 characters, theoretically it shouldn't print out the 11. No, it does. What? Wait, that means it's assigning, like, extra memory, which isn't good. Because what happens if I, like, just spam this with a lot of characters? Segmentation fault. from putting whatever that is. Right, but let's just say we spam a lot of characters. It can print all of them out back to us, except segmentation fault. That sucks. That's not good. So our scanf function is too powerful. Oh god. I don't like that. No, not mio.c, right. So our scan function like actually I don't even know like what would printing each one of the characters look like? Like is there a certain like ending character that it could print? Cuz like how does like assigning memory to the array work? Cuz like one thing I need to do is I need to somehow quit assigning oops, I just deleted a bunch of characters. Whoopsies while there. While pointer buffer, yeah. Cuz like I need to somehow understand how many characters there are in buff. And this. So I'm just going to go back to main.c and let's just try I also need to somehow print a number, right? Oh god. How could I print a size T? So let me just remove this. And I'll just, for now, I'll just try to, I'll add this into here. I'll figure this out later. So, void, print num, int num. For now. I'll move this over into a different function, fix it up, add like bases and whatever later. But for now, actually, wait. What are number ASCII characters? Wait. Oops, didn't mean to do that. ASCII table. Because I need to find out what the numbers are. Thank you for being... Numbers are 30 to 39. Right? So at 30... No, never mind. This is not saying me. This is telling me it's... Oh yeah, it's hex 30. So it's 48 through 57. So we add 48 to it, and it will do... And it will turn into a character. Okay, so that's how we can do that. Okay, that's fine. That's fine. Because we're giving it an integer, so it's fine. We have... and then we're just going to do string.h. So we have our libraries open right here. Just what we have. Okay, so... char c is equal to char of num plus 48. So then we just need to, and then oh yeah, I forgot, print. Actually, wait, no, that's not it. That's not it, because that's gonna give me one of the characters. But what if it's like a bigger one? How can we like split it up? How can we split up this integer into its own characters? I mean, technically, this would add or 48 to the num, so it would give me a nice debugging-based characters. So, for now, I'm assuming I can print a character, right? So we're gonna do print num. We're gonna do strlen of in. Right? Because we have our strlen defined inside of mstring, so I have to actually include it as well. Yes, okay, so now we have our strlen defined. So let me try to make segmentation fault. Woo! I love segmentation fault. Okay, so obviously that doesn't work. I think we have to do some like sort of pointer magic, but is there like a pointer to something that can only be a certain like one digit? A byte. Actually, that's even less than a byte. Yeah, no. One digit is 10. Up to there's 10 digits. Okay, right. Well, let me just search up if anybody has done this online. C string. No, int to string. Int to string. Let's see if anybody has done without. So the number of characters can be figured out with ceiling of log base 10 of the number plus 1. Okay. But again, I am pretty sure this iota function, it's not standard. Oh god. You know, all of these include some sort of standard library. Never mind. Okay. So iota. Okay, so check that the base is valid. So if base is greater than 2, or I mean smaller than 2, or greater than 36, result as, yeah, okay. Makes sense. Okay, this is like a really complicated function. But I think I can understand this, right? So we have a pointer, which is going to be equal to result. Another pointer, which is also going to be equal to result, and then just a normal char, which is going to be called temp char. And then int temp value. So temp value will be equal to the value that we've given it. Value divided by base. So value is equal to the value divided by base. And because value is an int, so I can actually, like, you know, I can do while value. So while it is greater than 0. And then pointer plus plus is equal to one of these, and then 35 plus temp value minus base value times base. If temp value is smaller than 0, print pointer is minus, else it doesn't. Okay. And then we reverse the pointer, because it's done this all in reverse. Okay, so I'll just put this in for now, and I'll recode it myself later. print iota of int, so that's the value, I think. What did I type it as? Num, just num. Oh wait, iota needs to be a char. So we need to create a char pointer, res, and base of 10. And then we're gonna do print res. Okay, let's see if this works. Undefined reference? What do you mean? It's right there. Oh, it's itoa, not iota. Yeah, no, makes sense. Would that put it into result? Theoretically it should. Okay. Still a seg fault. I'm assuming that's because this is returning a seg fault. strlen of in. What if I print num of like 324? Nope, it's still a seg fault. So apparently printing that somehow creates a seg fault. I think it may be because the char that I'm creating is like not. So what happens if I do char, and I'll remove the print num for now. Char C with 10, right? So it has 10 bits of memory in it. Then we're gonna do itoa of int value 324, whatever I name that char, C, and 10, base 10, print C, right? Make main. Okay, so yeah, that works. But if I turn this from one of this into a pointer, no, it also works. So let's just say we have our char 10, char in 10, right? And then instead of 324, we're gonna print an strlen of in. What is that gonna return? Zero. So that returns 0. That's because the last character is wait, does that like does doing that just make all of the characters in it terminating characters? Like if I do if in 0 is equal to terminating character, print 1. And then I go into visual, I just select this, yank, in 1 is equal to that, it'll print 2. That's I'm just gonna try to get as many of them as I can. So in 2, and 3, and 4, and 5, and 6, and 7, and 8. And I'll also try adding one extra one. Yeah, 9, 10. So, because this only goes up to 9. So what happens when I get a 10? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. And I'll put a question mark. Oh, it's already returning errors. Let's see if it even compiles like this. One, 2, 9, and 10. Okay, so obviously this one isn't gonna work. So now my question is if this is gonna work. I'm gonna remove print C. And we just want to know what each of the characters in this one is defined as. Make. So 1, 2, 9, and 10. But for some reason, all the characters in between that aren't. So how the hell am I supposed to figure out? Cause like, wait. So basically, like, in 3 is not a null character. Then what is it? So if I do, for example, like, what else could it be? Let's remove all the other ones for now. Or let's just try. So if in 3, so this is the one that didn't print out, for example, is equal to backslash, I don't know, n, let's try. Print E. One, 2, 9, 10. Okay, no, it isn't. Let's try if it is, for example, space. Or I mean, yeah, no, it can't be empty. Backslash S. Nope. Oh, unknown escape sequence. I guess space isn't that. Nope, still not. It still isn't. So what on earth is that character? Let's try also by print in 3. I don't know if this is even gonna work, but you know, let's just hope. Rm main make segmentation fault. So something about 3 is a segmentation fault. Okay, right. That's probably because, like, stuff isn't working inside of the print function. So let us just, instead of using the primitive print function, you know, the very easy one, to use a write with 1 in 3 and 1. It doesn't... it prints out nothing! Nothing! Is it defined as literally nothing? Hey, wait. I have two more theories for... First of all, if I put a pointer there... Is it gonna do something different? Yeah, no, that's just gonna... So what happens if I use an and like to reference its address? One, 2, 3, 9, 10, and it just doesn't, and then it just stops. Okay, so obviously these aren't working. So let me just remove this. Just, you know, clean it up a little bit. Okay, so then let's try if it is equal to void pointer of 0, like null. Nope. So it isn't null either. What on earth is it? Printing it gives us a segmentation fault. Printing us with its address gives us absolutely nothing. Which I'm assuming it's an address we want to be printing. Like, for example, let's just say, I just want to test that printing its address is what we do want to do. So let's just make... Let's just make a char e, give it like 2, and then let's put e1, or I guess let's make it, yeah, e1 is equal to e, right? And then we go ahead, we go write 1, and so the address of e1 and 1. So would this give me the, you know, the function that I want? Oh, I forgot I'm so smart. I forget a semicolon. I am so smart. Yes, that does print out. Hello, bean sauce. Oh, 6 sauce, whatever you change your name, it's still... Okay, so what happens if we print out without the ampersand? Yeah, okay, so you do need to have the ampersand there. So I know that. Okay, so in write, we're gonna quest to figure out what on earth it has assigned in 3 to be. So, I mean, let's just think of ASCII table, right? If we go to where we have all this stuff, right? Actually, what would be like the number of... First of all, maybe it's 0. Maybe it's 0. That is one option. Null. Start of header. Okay. Start of text, end of transmission. All this stuff. EOF for end of file, you know. Angry bell, acknowledged, backspace, horizontal tab, line feed, vertical tab, form feed, carriage return, shift out, shift in, data link escape, device control 2, device control 3, device control 4, negative acknowledge, synchronized, end of transmission block, cancel, end of museum, substitute, escape, file separator, group separator, a bunch of stuff. There's a lot of stuff that it could be if it doesn't print out a single character. It could also just be delete, but it isn't. No, it isn't delete. It isn't delete or backspace. I don't think it would be. So my main idea is that it's just null. It's just 0, right? If we just put equals 0. Prints out J? Excuse me? What? I am... Oh, no. Oh. I see. No, I see what's happening. So while a few of the values are always assigned to be terminating null characters, the characters in between, they seem to be assigned to weirder things. So how am I supposed to figure out the length of this kind of array of uninitialized characters? Do I just like trust that scanf will never end up getting like any extra random stuff? I'm gonna remove this for now. Do I just like trust that whenever somebody uses scanf, they don't like come up with a bunch of random stuff? When I, for example, use char in 10, right, and then I do scanf, but that's the thing, right? If I put in into here, the issue is if I put in into here, right? Then the user, which is the user at this point, it's not even the person writing the program. The user writes something longer than 10 characters. They write something that's longer than 10 characters, it's going to break the program with a segmentation fault. You know, the seg fault. Because what they wrote could be longer than the amount of space given to the program. Because we're gonna obviously write not scanf, print. It's just scan and it's print. Print in. So we're gonna write this, and we're gonna go into. Well, so why on earth is mio.h? Oh, because there is an mio.h. Okay, that's fine. That's fine. I'll remove it later. mio.c, right? If I go to mio, which has the scan function, like. Because how can I add a size, right? If I just add it to here, I will return right here, return. And we'll just have print. Actually, I completely removed the iota thing. So let's just say, let's just put int c is equal to strlen of buff. So we'll see how this works out, right? C++, right? Oh, what a great... We've implemented C++ into our code. So, while the buffer is not equal to null, and... Actually, no, C and int A is equal to 0. A++. And... No, just A. And A is smaller than C. So if C returns 1 here, this is no longer going to be smaller than C, so it's going to skip over and only write 1 character. And then the print function is going to So wait, if I just do, first of all, I need to remove src slash mio.h. So rm main make. If I just type it in, yeah, it isn't able to detect that. Oops, I just removed the entirety of mro.c. That is fun. That's not good. Our entire code. And, yeah, no, it's just gone now. So now I have to recode that entirely. That's great. Okay, right. And I don't think it like deletes it into bin or anything like that. No, it just completely removes it. Unless? Nah, it's all the stuff that I've used when trying to set up Vim. So no, it's got nothing. So that's fun. I have to restart the entire thing. Woo! Right, let's go back to getting read and write working. Okay, right. So, void write. Oh yeah, it already recommended to me. Oh, nope. Thank you. Thanks so much for being. Yes, oh yeah, I also need to do some definitions, which I'll put above the includes. Hashtag define. Sys read as 0. Hashtag define. Sys write as 1. Okay, right, that's great. Okay. Also make the ASM volatile, just, you know, because just in case anything bad happens. Syscall. No inputs. No outputs, I mean. And inputs for A, we have syswrite. For D, I think. Time to go back to this thing. No, not this thing. This thing. So, right. So, capital D would be FD. Capital S is buff. Okay. So, capital D would be FD. Capital S is buff. And lowercase d is count. There. And there. Okay, so now we have our assembly. Visual, select everything. Yank it. Just do that. Paste it in. Read. No constant. Sys read. And S, instead of being here as buff, it's going to be at the top. Equals S. Is it? Buff. Okay. So there we go. Now we have our read writes. You know. Let's go back down. Let's create our void print const char buff. and we're just gonna do write one. We're gonna have buff and strlen of buff. Where else is there an error? I think it's just void read or void scan char pointer buff, and my very smart logic is all of a sudden all gone. I'll have to rewrite this, but for now let's just say so buff read 0 buff 1 while pointer of buff is not equal to \0. I'm going to be doing buff ++ and read 0 buff 1. So there we go. We have our amazing function, and then what we have to do is just pointer buff is equal to \0. There. And this has to be instead of \0 \n. Okay. Right. Oh god, I just messed up somewhere. Yep, there. But as soon as I start writing over the limit, okay, maybe not for a bit, but you know, once you get a lot over the limit, segmentation fault. Woo! I love segmentation fault, and I have no idea how to fix it. The way that frickin' stupid variables are assigned in scanf is just impossible. Oh god. We need to we need to add some sort of system to prevent that. So how can I add optional arguments? I feel like I would need to add like a length argument, where it would return at most the length. So if I go back into MIO, right, and into scan right here, and I have just like a length argument, right, and I put read, so basically it will add to the length as well every single time it adds to buff. And then if the length exceeds a certain limit, it will just set the way I'd have to get it to work is I'd have to actually make it so that it always includes. I need to make, okay, let's just try this. Int lim. So int a is equal to 0. Buff ++ a ++. A is greater than is smaller than limit. So basically, if a becomes the same size as limit, it will quit. So theoretically, if I go to main, wrong file, and I say scan in 10, which technically means 9 characters at most. rm main make. Never mind. Oh yeah, because I forgot to update it in the header file, didn't I? Yeah. Let me first change. No, that's fine. That's fine. In my O, I have to scan right here. Oop. Size _t len. Or I guess I'll call it max len. Or I guess Just call it max. And then hashtag include. Oh, wait, no, it already includes mlib because the size t is already a thing. W. And then in here and MIO, I have to go into here, and then I have to quickly update that to be size t. Size t max. rm src slash main c. Okay, rm main make. Okay. I forgot to change that. First of all, let's just test it for that value. Okay, it works. And then let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. It should still work. But then if I put an extra 0 at the end, it still counts that. Okay, okay, maybe a bit later. Okay, right, it stops at exactly however many characters we asked it to, which is actually perfect. So, we asked it for, we asked it for 0 characters, or 10 characters, and it gave us back 10 characters. The issue is that cannot be implemented normally. Like, you have to give it a number of how many characters we can write into it. So basically, no matter what, scan will have to give you give us a size, because otherwise we can always overflow it by accident, or just from the user overflowing it, which is a bit sad, because we aren't like giving it memory, because we also don't have malloc, because that's also part of like one of the standard libraries. As you know, we only really have assembly and stuff like that, which is a bit, you know, sad. So, because I'm thinking, like, what else could I implement right now to make this easier? But I don't think there's anything I could implement, because there's no way of me making it so that you can have a no max, because the way like the character works is if I just quickly quit and I just go into main. The way this works is the character is just given a size, which is memory that it is given, but that size could have random bits of memory. It doesn't necessarily have to end in something, at least I don't think, right? Unless, I mean, it always ends in a \0 character, but then who knows how many \0 characters there are? Because there could also be \0 characters in them. For example, when we last tested, 1 and 2 were always set to \0 characters, and 9 and 10 were always set to \0 characters. So how am I supposed to know how many \0 or terminator characters there are in this string if I'm just given the string, and I'm not even given the size of the string? So I have to be given a size of the string that I'm... Unless... What does size of give me, right? So if I just give what happens if I give it size of in divided by size of in 1 or 0, I mean, right? Because that should theoretically still that works. That works. That works. And that works. Okay, so that does work. Thing is, can we find that out from inside of the MIO function. Because this isn't an array. This isn't an array. Because when given into here, we're given a pointer, not a pointer to an array. What if we use len here right now? How many is it going to give back? Because I'm assuming it's going to basically give back divided by, well, the size of a string pointer, right? Okay, so it kind of gives it back, but no, it doesn't really. It gives back, yeah, no, actually, yeah, of course, because that is pointer divided by the size of an integer, or I mean a char. The pointer to a char divided by the size of a char. But I don't have a function that will check the size of the length of this string that isn't defined. Well, let's just nvim e.c in the main directory, just so I have just so I can test it out. If I just include string.h, include stdio.h, and include stdlib.h, so this is the one time that I'll be using headers here. Int main return 0. Okay, so what if I just go to char hello 10, and then I go print decimal of strlen of hello. gcc e.co e. Oh. Long unsigned. Okay. lu dot slash e. 0. So their function doesn't find that out either. It works exactly the same as my function does. 0. So how can we, let's go back into here and let's just, because they have their amazing scanf. Wait, but when we put it to scanf, don't we have to put and? Because if I put scanf %s into just hello, would that work? If I then go printf %s like that, hello. Okay, would that work? First of all. Okay. What happens if we... Okay, so let's just add our 10 characters. So what happens if we overflow? Stack smashing detected. Terminated. Aborted. Core dumped. Okay, well that's even nicer than what my... That's much worse than what my guy did. My thing actually printed it out. But okay. Apparently we need to detect stack smashing and terminate the program if something like this happens. So what it's trying to do is it's trying to give more characters into hello 10. But what happens if we add if we scan into and hello. Okay, yeah, no, that isn't asking us for that. Yeah, no, okay, I see. So basically, if it is a string, okay, I'm gonna remove e and remove e.c. So first of all, I'm gonna make our own one, nvim. Let's go back. MIO. Okay, so honestly, our thing just terminates the program in one way, their thing terminates the program in another way. It works pretty well, not gonna lie. So yes, we could have a scan with a that. So instead, I'm gonna do that. I'm actually gonna use that for scan because scanf is gonna be the one that doesn't. Nope. So then let's start working on scanf. It won't be the same thing as printf, but it won't like allow for more than one option. So void scanf. So first of all, we're actually gonna have const char pointer f. I don't know. Just something. Actually, let me just see what the manual has to say about that. Scanf. So scanf constant char format and then all the args. Okay. Const char pointer format dot. Okay. We are only gonna accept one argument because I don't really think I could do that. But basically, we're gonna need to find first of all if if we're gonna make another pointer. And this was going to be an int pointer. So int pointer is equal to int pointer of format, I think. I think that would work. Then we're going to do ptr plus equals. We're going to add on to it. Well, size of format divided by size of int pointer. Hopefully that allows me to get the first argument. Then, say if pointer format is not equal to %, we'll do a few mean things. You know, we're gonna make this harder to program. Oh, more people showing up. Wow, everybody said E in chat so far. That's cool. Wow13 says E. Okay, so if the format isn't that, we're gonna print invalid format scanf. Now I can't really throw errors because I don't really know how to. So for now we'll just say that, and it's going to return. In fact, I'm going to be extra mean, and I'm going to go for what is it called? It's going to be like process, because I have stdlib, right? mlib, yeah, mlib, and in mlib there's like a exit. What is it called? Wait. In mlib, it's process error. Yes. Could I process an error? Process error. Yes. Process error 1. There we go. and say select the 12. I could do that. Or I could just, like, not do anything. Make it not work. But make, like, the user understand that something has happened and their input was not invalid format scanf. Okay. So then we're going to do format plus plus. So we're going to do... Well, okay, so if pointer format is equal to s, so basically if it's asking for a string value, and this is the only thing I really cover. I mean, I'll cover an int as well. So, if it's an int, I'm just thinking, because that would be a char pointer, right? That we're going to need a set. So we're going to put then char pointer c is equal to char pointer of ptr, and then we're going to do read, or no, not read, just scan ptr. And that's the thing, I do not know the size of it. How would I know the size of it? Because size of would return... And size of just pointer of that would return the value of... I'm just thinking, what could I do? Maybe... Because I can't really use size of here, because that's just going to give me size of the first element, or the pointer. I don't really know what I could do. How could I do this? Because, like, I need some sort of pointer. I mean, I need some sort of size. This is actually quite confusing. And I have no idea how I could do this.
Let's see if the internet has any answers. Unless, because that's giving me the pointer to the array. So what if yeah, so what if I use this? Because, like, this is technically a pointer to an array, right? Right? I think, maybe, potentially. But let's just say we scan C and then size of pointer C divided by size of a char, because it's a char array. So technically, that's how it would work, right? Let's see what this does, right? If I go to main, and instead of scanning, I do scan F as percent %s. First of all, if that even works, and then we just pass in C, or I mean in, because in. Or maybe if we pass in and I'll try this first, and then I'll try passing in ampersand in. Oh wait, MIO. Yeah, why am I putting in C? Char C is just the pointer for char. So actually, I do need to put char C, but not the pointer. Make. Okay. Ah, God. Oh, that's because that happened. Okay. Segmentation fault. That is great. So let us just go back into main, and let me put, instead of just in, I'll put in ampersand in. So the address of in. So technically that would be an address to a string array. So I'm gonna try that first of all. Nope. Instead, okay, I have a separate idea in MIO. Instead of this is char C array, pointer to a char array. I think that's how it would work, right? Char array pointer. Sure. We're gonna give it the array size of pointer C. Yeah. So that would have the array entirely. Oh God. So that cast definitely doesn't work. I'm not entirely sure. Function scan F, an invalid initializer. What? Let's just remove this entirely. Actually, wait, that won't be a pointer to an array. That would just be an array. I might have to cast that to a... Well, first of all, let's try... First of all, let's try by pointer at that. Nope. Alright, in that case, let's try char. Because I don't know what the length of it is, though. Oh god, this... It's always asking me for the length. So I'll make pointer C. And then C is equal to PTR. Still weird stuff happens. So it takes up the it eats up the first character. Just segmentation fault this time. It doesn't even give me a chance. But the thing is, I can't initialize it. I can't initialize it because I don't know how long it's going to be. So, unless I do pointer C0 is equal to BTR, yeah, but then it's uninitialized. Wait, because we don't know what the array is. we can hopefully maybe initialize it with some like pointer functions. Maybe. Okay, so it's not giving us seg faults anymore. The question is, how long is this? Four. Four. So this is giving us 4. Which I find a bit weird. But let's just go to main. And let's increase the size of this array to 20. Would this in any way affect it? Probably not. Yeah, still 4. Still 4. Oh yeah, no, that makes sense. Yeah, no, it's not. So let's see. So we need to somehow, out of this weird pointer that we have, figure out the size of the array. Well, what we do know is that this pointer is pointing to us as just surround this all in brackets. There's gonna be a lot of brackets here. So this is the value of what is a char array pointer. And the thing is, I don't know if that's possible to necessarily write. Yeah, no. Cast specifies array type. Yeah, I know. What happens if it's just a char pointer? It's just gonna say hi once, no matter what. Which makes a lot of sense. The thing, this isn't
a pointer to a char. This is a pointer to a char array. The address of a char array. I'm so confused. How could I possibly figure out the length? I'm gonna try searching a bit more about this. Yeah, because this is in the same function. See? Array pointer function parameter. Let's see what this has to say about it. Okay, right. So if we just turn that into a pointer, we can get b and then like a certain number. We wait, pointer to b here. So basically, I get a pointer of an int. So what if I turn this into a pointer of a char array? Yeah, no, that. Okay, let me just, instead of this, I'll try to do what they did, or something similar to what they did. So char C, I'm gonna remove the scan for now. So char C, which is what they have, well, I mean, it's actually pointer C. In this case, pointer B is equal to the pointer that I've been given, right? Could I then
say print C 0. Because if I can, that means I can get the length. No. Did I cast it wrong, or? Because it should be a char pointer. Yeah. Well, that's great. I already made a seg fault. You know that's good. And that's because of this. That's because we're trying to access C0 without knowing that. How do they initialize it? Yeah, just normal function. You should probably try to initialize it like that as well. And then they send it in, and that's the argument. That's the thing. That's a weird argument as well. Incompatible integer to pointer conversion. Oh yeah, no, it has to be. C pointer, right? They did, yeah. So pointer to C. Pointer to C 0. Subscripted value is neither an array, nor pointer, nor vector. Oh god, I hate this. But it is an array. It is. It is an array. Oh my god. Yeah, no, but I can't have this be initialized as an array. Let me see what they did over here, right? So let's actually try to do this, right? Scan. In the normal scan. For now, scan F. I'm just gonna format as S. We'll have to figure out the string stuff, but not right now, because obviously this is like done by like wizards or whatever. So instead of a size t max like this, we're gonna put buff, the pointer buff into here, and then we're gonna put an array like that. We're gonna say size t max is equal to size of pointer buff divided by size of pointer buff 0. So I'm gonna no longer do this. I'm just gonna give in to scan a pointer or an address of. Oh God. Okay, so first of all, too few arguments to function scan, even though, oh yeah, because it's a header. A bunch of other header stuff. Conflicting types. Declaration. Okay. Invalid application size of to the incomplete type char. Thank you. So instead of buff plus plus, I just have to write buff I. Pointer buff I. So, first of all, actually, I'm gonna go ahead and I'm gonna quit, and I'm gonna do. Okay, so that we'll figure out later. So we're gonna comment this out. Like that. Try just adding this. Okay, so the only part that failed is the size of. How could I fix this? How could I find the size of a pointer to an array given to a function? Here's of pointer of array from pointer. So, no, you can't do this. So we can't actually. So we actually do need to go back to having a max function. That's basically short answer, no. Short answer, no. Long answer, no. Just needs to be a char pointer and size t max. I'm a little confused as to how we were using scanf. const char mat f const char format dot dot dot. Okay, so we need to figure out something. Also, let's quickly go ahead and edit main there to be scanf. Okay, so we need to somehow figure out how to create format. And this is very confusing. I'm just thinking. What could I do? What could I possibly do at this point? I'm just thinking. Maybe, because we know that PTR points to the start of the next char array. I mean, what we do know, all that we do know, is that it is a pointer to a variable where we can store the next. What we don't know is the size. Thing is, using scanf, it just tries to fill up the size. And if you fill up more, it will just return an error. So what I'm thinking is we just scan with a max of, well, integer limit, and if the user overflows the amount of space given, it will just break. So we can say char pointer c, pointer s, I'll put pointer str is equal to is equal to char pointer for PTR. Then we will just try to scan, because again, it isn't a defined size, it's a max size. So if we try to scan into str with integer limit, which we need to define that in math.h, I think that's where we could define this, right? We don't define mbcur max. This macro is the minimum number of bytes in a multi-byte character. Exit success, exit, no, macros. Any other macros maybe? Around here? Argument, no. Qualifying input, wait, that's just a library function. Scanf. Inside of this one? Null inside of that. Macros which are integral constant expressions. The size of the buffer. End of file. Actually, inside of stdio.h, I should probably actually write this because it seems quite simple. For now, we'll add one. Just to give this. Yeah, first of all, we gotta fix that up inside of MIO. Size T max. And second of all, inside of, that's an stdio, right? We have std in and out. So hashtag define std in as 0, hashtag define std out as 1, and hashtag define std as 2. There we go. That's pretty nice. Okay, we're gonna create, I'm assuming math.h has it, right? No, that has huge val. So I guess we're not gonna define any of these. Okay, that's fine, that's fine. In that case, we'll just give it a large number. Oh yeah, I forgot this isn't, okay. What should we give it? Like for max, it should not have a max. Which means, instead of a size t, nah, it's fine. We'll just give it, well, I don't know, 2.5 or something like that. 2 million. Like, I don't think anybody's writing more than 200,000 even. Maybe 20,000 is more than enough. Although at the same time, I do want to open availability. Now, what did we make? What did we define size t to be? Unsigned, just unsigned. Just unsigned. So where are these, right? Where are these int max and... Oh, limits.h. Okay. I gotta make that then. It only has definitions. Okay. That's really nice actually. That means that I can make that right now. mlimits.h. Hashtag if def underscore mlimits underscore h. Hashtag define underscore mlimits underscore h. Hashtag and if. And wait, now in here we're gonna define all of these. So all of these integers, all these values, we have to define. Hashtag define char bit as 8. S char min is minus 128. S char max is 127. There's 127. uchar max is 255, char min is minus 128, char max. Okay, so uchar char max 255. Wait, uchar? No, just char. It's char. Char underscore max of 127, right? Because no, yeah, 127 score min minus 128. Let's scroll down. So yeah, plus 127. So we have MB len max. What is MB len max is 16. Right? Shirt min 32,768 minus 32,768 minus 32,768 2,767. Then what else do we have? U shirt max is 65535. Yeah, 65535. Int min is this. Oops. Okay, that was mediocre, but you know, it's fine. It's fine. Okay, we have int min and int max. Uint max what else do we need? Log min, log max, and ulong max. And equals a minus paste. Hashtag define log max as paste that 7. Hashtag define ulong max as this massive number. I think that's all the definitions. Yeah. Okay, so there we go. Now we have an amazing library made. Oh, did I just... Yeah, what this is. Okay, whatever. No, that's the wrong one. MIO. Now we can include, at the top, my amazing library. mlimits. And then because signed t is an unsigned int, we just put in here u int underscore max. There we go. Okay, right. Now make. Oh no. That sucks. I think I added a few too many. There might have been some issues there, I think. Let's reopen our terminal. And vim. So in main, it just asks to scan a character into in. Now, what does it do in MIO? So scanf. So is s. It does go into there. It does start scanning, and it will suppose. Well, I mean, it's supposed to do. Is it supposed to scan? Oh, I see. Yeah, no, that makes sense. What it's supposed to do is it's supposed to scan until buff reaches \n. So it's gonna read one character into buff. So wait. Instead of unit max for a second here, let's just use a max of 20, which is more than what our thing allows for. So rm main make, right? So we write hello segmentation fault. Why? What did I do wrong? Well, I mean, it did get me the extra ones after the hello dumped, which shouldn't have happened for that many. Okay. I mean, this works, at least, I think. Now the thing is, I think there's something about turning that back into a pointer. I think what I might have to do is I might have to just turn this into its own char pointer. Char pointer. Then, instead of making all of this, we could just go for pointer. Oh god. Even more crap. Oh god. Okay, I'll do a different thing. I'll actually just copy over the code from scan into here in a slightly different way. So we're gonna read into PTR. It is a pointer. Into PDR, read as 0 first. Into PDR, one character. Then, while pointer of PTR is not equal to \n. So we're going to completely remove the whole like size limitation. PTR plus plus
and read zero ptr 1. And then pointer ptr is equal to Terminator character. Okay, also I'm going to replace these with std in. Read right here std in. Write is std out. Okay. So I've just copied that over. So basically the pointer is now pointing to an array of characters, and I've given it the pointer to the array. Maybe I should give it the... Nope. Okay. In that case, let's go to main. Let's give it the this. Nope. Still does stupid stuff, and I don't really know how to fix this. Nah. Scanf really does not want to work. Apparently warning's right here, first of all. That's the first thing. Maybe I should have looked here. Pointer format. Because that returns the array itself. So maybe, all this time, just giving it the an address to an array, it wasn't actually getting to the array. Well, oh, it gives us up to 10. It doesn't allow us to enter less than 10 then. And then it just does a bunch of seg faults. And now I'm confused again.
I think maybe scanf is a lost cause. I don't really know what to say. Like, legit, it is so weird. I think scanf for now has gotta go. I mean, I already did some good stuff with this. So for now, I think no scanf. And instead, I think we gotta just, you know, take that, click that button, and you know, it's all gone. We have our scan function, okay? We can scan in a string, at least. We can make the most basic programs so far. Oh god, this is hard. I was thinking how we would work with printf. If I don't know if whether that's just because like the pointers didn't work, or just because I was trying to write into pointers that like were saved in a different section of memory, and reading them would be perfectly fine. Like, could my printf function work properly? Like, if I read the pointers like that, the way I did. Well, I don't know. I've been streaming for 3 hours now. And in those 3 hours, we've got at least some things working. So let's just end off the stream here for today. I'll be back tomorrow probably, or maybe even later. I don't know when, but sometime I'll be back to stream more. To stream more of this. I mean, we have main.c here. We have made strlen. We have made print. We've made scan. What else have we made? Let's just look through it. Right, we've made int main coming from the what do you call it? Void start. We have actually made an int main that works like it's supposed to. We've made our process error, which would obviously say whether the program finished successfully or with an error. We have sysexit, which exits the program, which which is one of the harder parts because assembly. But actually, assembly I find easy now. What I find hard is being able to parse those like variable amount of arguments thing, which has somehow to work without the stdarg lib, which we'll have to make ourselves probably. We have our write, read, print, and scan function with write and read talking directly to the computer via assembly, and print and scan have a layer of abstraction on top of them with, a bit of also understanding the length and, not having to understand file descriptors or anything like that. And the same thing goes for scan. And we have our strlen coming from mstring.h. I personally think for today this is quite a success. And yeah, I think personally I'm pretty happy with what came out of this, because we can enter, we have all of our things. Yeah, print in. We don't have a scan. So yeah, honestly, I'm happy with it. Oh yeah, one thing I'll do actually before I go is include mlib.h. I'll define exit success as 0 and define exit failure as 1. So now if we now if we go into the main function, we can also return as exit success and exit failure.
And you know what I'll also do is I will actually go into... I want to end off the stream, but now I have ideas. I have idea of nvim src/mio.c. I have the idea of making a get and put, or I guess puts and gets, or whatever you call it. So void puts is equal to with const char pointer buff, and that will write, or I guess that will just do print buff, and then void gets, which would be like a more dangerous version of scan, because you can't really set like the buff size max, would be with a char buff pointer buff. And because we have no way of figuring out what the size of that is, I don't think at least. Could we? Actually, now I'm curious. What happens if I say for int I equals 0, I smaller than, and then I'll just quickly write this size of pointer buff divided by size of char I plus plus. We're going to print hello. And then we're gonna write inside of the main, we're just gonna write gets, I'm gonna see char in 10 gets and in. One. Okay, now what if I go to and I type in without? No, okay, so it doesn't matter. That's never gonna work. And should be the correct one. Okay, so in here we're just gonna say scan buff and uint max. So you could go forever theoretically with this. My question is combining strings? I'll try that next time. Also, I need to switch around read and print. Because this should be print. And this one should be read. I'm just gonna do that, so... const char pointer buff. Okay, and then void gets char pointer buff. So for any up to 10, it's gonna work all fine, but then if I add more than 10, apparently it's also gonna work fine. Okay, so I guess it's gonna work fine until suddenly something bad happens, like way too much data. Which is why it is a dangerous one. So gets is a dangerous function because it doesn't limit the person. But, you know, that's fine. So yeah, that's the end of the stream. I've been streaming for how long? 3 hours, 10 minutes. I think that's about as far as I'm gonna get for today, and I'll see you guys in the next stream then.